Okay, so we're going to shift gears and we're going to talk about power series for the next few days now. Okay, so yeah, so let's talk about what a power series is and how to attain one and some of the common ones that are out there. Okay, and yeah. Okay, let's jump into this stuff. Cool stuff. Okay. Yeah. Let's do the screen share again. Share my screen. Oh, let me turn my camera off. Their camera goes off. It's a good sign. Okay. Camera off. And let's bring up the notes. 11.8 notes. Okay, we'll just start on these. Okay, so 11.8 is power series. I got the power. Power series. Okay. So a power series centered at A or centered at 0, okay, looks like so. Okay, it's a series. It's just a special series. Okay, and this is it's a geometric series. Ooh, nice, geometric series. Okay, those aren't too bad. Okay, if it's centered at 0, it looks like this. The summation of n equals 0 to infinity of c sub n, that's a constant at n, and then x to the nth power, where x is a variable now. Okay, so variable. It's a geometric series, but it's a geometric series of a variable. And this creates polynomials. It's a polynomial generator. Okay, this creates polynomials. Okay, polynomial generator. Okay, so we're going to say this is c sub 0 times x to the 0, which is, we'll see what that is in a second. C sub 1 x to the 1, c sub 2 x to the 2, c sub 3 x to the 3 plus forever, right? Okay. Okay. So what is x to the 0 though? That's 1, right? This thing is 1. So this just becomes c sub 0 plus c sub 1x plus c sub 2x squared plus c sub 3x cubed plus dot. Okay, plus cn x to the nth plus, and it just goes on forever. Okay, so you can get your nth term that way. Okay, so if it's centered at 0, it looks like this. If it's centered at a, at the value a, it looks like this. Okay, n equals 0 to infinity of c sub n x minus a to the nth power. Okay, so then this thing is equal to c sub 0 plus c sub 1 times x minus a plus c sub 2 times x minus a squared plus, and that just goes on forever. Okay. Oh, a is, wait, well, that's right. Yeah, that's correct. Okay. So let's talk about converging power series. Okay, which power series converge and which ones diverge? Okay, so number 1, for what values of x does the series okay, for what values of x does the series summation n equals 0 to infinity of n factorial x to the nth converge? Okay, for what values of x does this series converge? Okay, well, let's do the ratio test on this. Okay, well, we want to find out, well, where is this thing absolutely convergent? Okay, where is this thing absolutely convergent? Let's do a ratio test. Okay, because if it absolutely converges, we know it converges, right? So where is this thing absolutely convergent? Okay. So we're going to take the limit as n goes to infinity of a sub n plus 1 over a sub n. Okay, and we're going to say that the limit as n goes to infinity of n plus 1 factorial x to the n plus 1 all over n factorial x to the nth, right? Okay, we want the absolute value of that. Okay, so let's see what this equals. Okay, so this is going to be the limit of n goes to infinity of, this is going to leave me with just one x. Okay, so this is going to be x to the n over x to the nth, but then I have that extra x. So this is going to be n plus 1. Okay, I'm going to put that little extra x in front, n plus 1. This is going to be times n minus 1, dot, 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 forever. Okay, until I get to 2 times 1, done. Okay, what's n factorial? N factorial is the n times n minus 1, dot, 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 2 times 1. And so what's going to cancel? Everything except the n plus 1. So this is the limit as n goes to infinity of x times n plus 1. Oh, okay. So this is just an x, k times n plus 1. Well, we'll plug in infinity, what happens? Well, this thing just goes to infinity. It's x times infinity, which is just infinity. So this thing just goes to infinity, so this thing diverges. Okay, so this thing is greater than 1, right? That thing is greater than 1. The thing just keeps going. Okay, so does it converge? No, it does not converge. So this thing diverges. Okay, so this thing diverges for all values of n except what? Except 0. Okay, all values of n. Okay, so it diverges. It's going to keep going up and up and up and up and up. Okay, or sorry, for all values of x, except 0. 0 is the trivial case where this thing. But if x is 0, then we don't really even have any. I mean, I don't even really need to. I'm just going to say it diverges. Okay, it diverges for all values of x except 0. But if it were, if x were 0, then the entire power series would look like, right? So if we listed out the first few terms of this thing, n equals 0 to infinity of n factorial x to the nth, right? What would this look like? This would be 1 factorial x, or sorry, 0 factorial x to the 0 plus 1 factorial x to the first plus 2 factorial x squared plus 3 factorial x cubed plus da, 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 right? Okay, and so this thing would just be 1 plus x plus, this is 2x squared plus 6x cubed plus 24x to the fourth plus forever, right? Okay, and then we're saying, well, what's the only value, this thing, what's the only x value where this thing is going to converge? The only x value where this thing is going to converge is going to be 0, because if I plug in x equals 0, what does this thing converge to? It converges to 1. Everything else goes to 0. So it diverges for all values of x except 0. Okay, if I plug in anything other than 0 here, this thing's going to diverge. Okay, number 2. Okay, for what values I'm gonna wait for this thing to catch up. For what? It's not working. I'm gonna stop my share for a second. Get this thing to work. And then I'll resume sharing in a second. Okay, for what values of x does summation n equals 1 to infinity of x minus 3 to the nth power all over n converge? For what values of x does that thing converge? Okay, so again, we're going to try the ratio test on this. Okay, because what? Because I know what? I know that if the limit as n goes to infinity of this thing is less than 1, then it converges, right? Of a sub n plus 1 over a sub n. If it's less than 1, if I can get that thing to be less than 1, then I win. Then that converges, right? Then it absolutely converges, which implies convergence. Okay, so let's see what happens here. Okay, so I'm going to say that this thing, x minus 3 to the n plus 1 all over n plus 1 all over x minus 3 to the nth all over n. Okay, for what values of x is this going to be less than 1 when I take the limit as n goes to infinity? Let's see what happens here. This thing is going to be x minus 3 to the n plus 1 all over n plus 1 times n over x minus 3 to the nth. Okay, let's take the limit of that as n goes to infinity. And when is that less than 1? Okay, for what values of x is this less than 1? Okay, so this thing is going to cancel with that, leaving me with just 1x minus 3. Nice. This thing is just n over n plus 1. And as n goes to infinity, what does this thing go to? What does that go to as n goes to infinity? Any ideas? What does n over n plus 1 go to? Think of asymptote. What's the asymptote? What's the horizontal asymptote here for n over n plus 1? Well, there's the same power, and they've got 1's in front. So what's 1 over 1? It's 1. Okay, and so this thing goes to 1. Okay. So, oops. Let me undo. No, forget it. Okay, so n over n plus 1. Okay, so that thing goes to 1. So we want to know when is the absolute value of this thing, which is going to 1, less than 1. When does that occur? Well, that's when the absolute value of x minus 3 is less than 1. So what values of x satisfy this relationship? What values of x satisfy this relationship? Okay, so let's see. This is going to be -1 is less than, not or equal to, is less than x minus 3, which is less than 1. Let's add 3. Okay, and then we get 2 is less than x, which is less than 4. Okay, so as long as x is between 2 and 4, we know it's convergent. Okay, the problem is, well, what happens if it's equal to 2 or equal to 4? What happens if it's equal to 2 or equal to 4? Do we know? We know that if it's outside this, it's bigger than 1. Does that make sense? If it's not inside here, if it's not in here, okay, if it's not in there, then it diverges. In here, it converges. Okay, so outside this, it diverges. But we don't know what 2 or 4 would be because that would be equal to 1. Does that make sense? We don't know. So what we have to do is we have to test the endpoints. So test the endpoints and see what happens here. Well, what was the original function? The original function was n equals 1 to infinity, right, of x minus 3 to the nth power all over n. Okay, so what happens when x is equal to 4? Let's try 4 first, because 2 is going to be a pain in the butt. Okay, so let's try 4. When x equals 4, then what do we get? We get 4 minus 3 to the nth power over n, which is 1 to the nth power over n, which is 1 over n. So I know that it's divergent, right? It's divergent. It diverges if x is equal to 4, because this is the harmonic series. That's harmonic. And since it's harmonic, it diverges. So when x is equal to 4, it's divergent. Okay, so if I were to look at my interval 2 to 4, okay, can 4 be included? No, so I'd put a parenthesis there. Okay, 4 is not going to be convergent. Well, what about 2? Let's look at 2. Okay. Okay. So when x equals 2, what do we get? We get the summation of 2 minus 3 to the nth power over n, right? N equals 1 to infinity. I should probably include that here. N equals 1 to infinity. Okay, and so what is this? Well, this thing is an alternating series. That's -1 to the nth power, n equals 1 over n. And is the alternating harmonic, is that convergent? Yes, this converges by the alternating series test, by AST. Okay, so that is convergent. So 2 works, but 4 does not work. So it would be like that, right? We would include 2, we wouldn't include 4. So for what values of x is this thing convergent? Right here, 2 to 4. Okay. Okay, let's see what else we got to talk about today. Okay, number 3. Okay, find the domain of the function. Find the domain of the function defined by J naught of x equals the summation of n equals 0 to infinity of -1 to the nth power x to the 2nth all over 2 to the 2nth n factorial squared. That's the big one. Okay. So I want to find the domain. I want to find out, well, for what values of x is this thing defined? Right? What's the domain of x? What can the x's be so that this thing has a sum, is convergent? Okay, is convergent. For what values of x does this thing converge? Okay, so let's see. Okay, so we're going to do ratio test on this thing. Okay, the limit as n goes to infinity of a sub n plus 1 over a sub n is equal to the limit as n goes to infinity of, this is going to be pretty huge. Okay, a lot of stuff going on here. -1 to the n plus 1 times x to the 2 times n plus 1 all over 2 to the 2 times n plus 1 times n plus 1 factorial squared, okay, times, now I'm just going to multiply it times the original flipped upside down, if that's okay with you. I'm going to skip the one step that I just don't want to write this all over and over again. Okay, times 2 to the 2n times n factorial squared all over -1 to the nth x to the 2n. Okay, so that's absolute value bars. Okay, now a bunch of this stuff is going to clean up. Okay, so what's going to clean up? The x's are going to clean up. The -1s are going to clean up. The 2's are going to clean up. Okay, so what happens if I distribute my 2 here? Wouldn't this be 2n plus 2? And wouldn't this be 2n plus 2? Right? So wouldn't I be left with -1 on top? -1 on top, right? What would I be left here with the x's? Well, the 2n is going to cancel with the 2n, but then I would have been left a 2, so that's x squared, right? So that's just going to leave me an x squared there. What about on the bottom? Same premise. This guy is going to get canceled with this guy, leaving me a 2 squared on the bottom, right? So cleaning all that up, what are we left with? Well, we're left with the absolute value of -1 over 4 x squared times n factorial over n plus 1 factorial quantity squared absolute value equals the limit as n goes to infinity. We want this to be less than 1 because it will be convergent if it's less than 1. Okay, cleaning that up as we go. So this is -1 over 4 absolute value. So I'm going to break up the absolute value here. The absolute value of -1/4 is just 1/4. Okay, times the absolute value of x squared times, which is just x, right? I mean, we're going to clean that up in a second. okay, times the absolute value of this thing. Well, what's n factorial over n plus 1 factorial? Isn't that just 1 over n plus 1? So everything else cancels out, right? And that would be squared, right? This whole thing's squared, which is going to get rid of the absolute value as well. Okay, so is less than 1, okay, equals the limit. Oops. The limit as n goes to infinity, okay. So this is equal to, okay, 1/4 x squared. Well, let's do it this way. Let's go 1, just go x squared over 4 times n plus 1, right, squared. Okay, and when is that thing less than 1? When I take the limit as n goes to infinity. Well, when I take the limit as n goes to infinity of this thing, okay, then goes to infinity. Well, what happens when n goes to infinity? Well, doesn't this just become x squared over infinity? Which basically, it's negligible on what the x is. This always goes to 0. That always goes to 0. Okay, and isn't 0 always less than 1? Well, yeah, 0 is always less than 1, which means that it didn't matter what x is. You could plug any x you wanted in there, and it's always going to converge. So we would say that this goes from negative infinity to infinity. That's the domain. The domain of this thing, or we could say that the domain of j naught of x is all real numbers. Okay, it's just all real numbers. Okay, let's look at the theorem here. Okay, for a given power series, okay, for a given power series, the summation is n equals 0 to infinity of c sub n of x minus a to the nth power. Okay, there are only 3 possibilities. There are only 3 possibilities. Okay. Okay. What are those possibilities? 1, the series converges only when x equals a. That is when the whole thing equals 0. Does that make sense? It only converges when x is equal to a, or when I'm just adding 0, 0, 0, 0, 0, 0, 0. Well, of course, a series that adds all zeros. This is 0 plus 0 plus 0 plus 0. Yeah, what is that going to converge to? It's going to converge to 0. Okay, that's just the trivial case. This is the trivial case. It converges to 0. Goes to 0. Okay, so it has 3 possibilities. It either converges only when it's equal to a. Okay. Okay. Or 2. Okay, the series converges for all x. Okay. Or the series converges for all x values. Didn't matter what x was, it's just going to converge because it's convergent. Okay, it's just that's the way it is. Okay, it's going to converge. Okay. And then 2, and 3, Okay, the one that's most interesting is the series, okay, converges when the absolute value of x minus a is less than r for some positive r positive, get rid of that, positive, okay, r, and diverges for x minus a greater than r. Okay, where r is referred to as the radius of convergence. Okay, and so in the one that we did before, the radius of convergence was 1. Okay, where well, I think this was example 2, right? So the radius of convergence is 1. Why? Because if you think of it as a radius on a number line, you've got your 3 here, you've got 4 here, and you've got 2 here. Well, this is a radius on the number line. Well, what's the radius? It's 1, right? So the radius is 1. Okay. Now it's only one dimensional, but you think of it as a 2-dimensional circle. This is a radius of 1 unit in both directions. Okay, starting at 3, we're going out 1 in both directions to get our 2 and our 4. And that was 1 here. Okay, sometimes it's not 1. What if we ended up with something like this? Right? Wouldn't we have to multiply both sides by 2 and then the radius of convergence would be 2? Yes. Okay, so it's not always 1. Okay, but we do end up with a radius of convergence sometime. In this case, for example 2, okay, the radius of convergence was 1. End up being 1. Okay, right here. Radius of convergence is equal to 1. So, okay, in example 2 then. Let's look at a radius of convergence real quick, and then we'll finish up for today. I think, yeah, I think we'll be good. I don't know. We'll see. Yeah, I'm not going to go into 11.9. I think covering 4 sections is a little too much in one day. So I think we'll be good. Okay. So let's just okay. Let's let this be our last example for today. Okay. This is our last example. Number 4. Okay, find the radius of convergence and interval of convergence, aka domain, interval of convergence, aka domain. Okay. I'll put domain of x. Okay. Radius of convergence and interval of convergence for, okay, for the following power series. For the summation n equals 0 to infinity of -3 to the nth power x to the nth all over the square root of n plus 1. Nice. Okay, so let's set up our ratio test to find our radius of convergence. So we're going to, okay, so the limit as n goes to infinity of, okay, this is going to be -3 to the n plus 1 times x to the n plus 1 all over the square root of n plus 1 plus 1, right? So it's like n plus 1 plus 1, all over the original, negative 3 to the n, x to the n, all over the square root of n plus 1. And we want to know, when is that less than 1? For what values of x is this thing less than 1? That's a really big one. Okay, when is that thing less than 1? Okay, as n goes to infinity, okay, so let's clean this up. Let's clean this bad boy up. Okay, so the limit n goes to infinity of negative 3 to the n plus 1, x to the n plus 1, okay. 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 Over, I'm going to rewrite this as n plus 2 to the 1/2. Okay, n plus 2 to the 1/2 times, this is going to be n plus 1 to the 1/2 power, all over negative 3 to the nth. Okay, the negative 3 is being multiplied, by the way. It's not negative 3 to the nth, it's negative 3 to the nth power. Okay, x to the nth. And that's it. Yeah. When is that thing less than 1? Okay. So the negative 3 is going to clean up because I'm just going to be left with 1 negative 3. The x's are going to clean up because I'm just going to be left with 1x. Okay. And let's look at that. That's the absolute value of negative 3x times n plus 1 over n plus 2 to the 1/2 power. Okay. I want to know the limit as n goes to infinity of this thing. When is that less than 1? Well, what does this thing go to? N plus 1 over n plus 2. What is that thing going to go to when I take the limit of that thing as n goes to infinity? Yep, exactly. Thank you, Victor. Thank you, Sterling. That thing goes to 1. Exactly. Okay, and you can prove that to yourself if you really want to. Take L'Hopital's rule. You're just going to get 1 over 1. Okay. Well, actually, you'd have to deal with. I would just take L'Hopital's rule of the inside, and then 1 to the 1/2 power is 1, and you can just prove it to yourself if you a bunch of ways if you wanted to. Okay. The limit of this thing is going to go to 1. Okay. So this is really just the absolute value of negative 3x is less than 1. Oh, okay. What's the absolute value of negative 3x? Well, that's just 3x, right? Or 3 times the absolute value of x is less than 1. Oh, okay. And so this divide by 3, and so we get the absolute value of x minus 0 is less than 1/3. Oh, okay. Absolute value of x is of less than 0, minus 0 is less than 1/3. So this would be our a, right? This would be our a. A is 0. Okay, and so what's our radius of convergence? Well, our radius of convergence is r equals 1/3. That's our radius of convergence, right? So the radius of convergence is r equals 1/3. Oh, okay. And so, yeah, that's the first part that we wanted to answer. And then the second part is, what's the interval of convergence? Well, here I've got to test the endpoints, right? Because it was the absolute value of x is less than 1/3. So this is really negative 1/3 is less than x, which is less than 1/3. The problem is I don't know about the endpoint. So we've got to plug those endpoints in and see what happens. Okay, so let's plug in some of these values here. So let's look at the original series. The original series was -3 to the nth times x to the nth all over the square root of n plus 1, right? Okay. So let's plug in, let's first plug in, let's do 1/3. Let's plug in 1/3. Okay. This is n equals 0 to infinity. Okay, so let x equals 1/3. What's going to happen here? Well, this is going to be -3 to the nth. Sorry, this is the summation n equals 0 to infinity of -3 to the nth times 1/3 to the nth all over the square root of n plus 1. Okay, so what is this? Well, that, I can multiply those together and that just becomes -1 to the nth, right? Which is an alternating series. So by the alternating series test, this thing would converge. Okay, let's see. So this is the summation n equals 0 to infinity of -1 to the nth over the square root of n plus 1. Okay, so how do I know that by the alternating series test this converges? Well, look at 1 here. Does b sub n plus 1, is that less than or equal to b sub n? Okay, so b sub n plus 1 less than or equal to b sub n. Okay, well, are these terms decreasing? Yes, they're decreasing. Okay, so is 1 over the square root of n plus 2 less than or equal to 1 over the square root of n plus 1? And yes, that is always true for any n. Okay, what about the second one? Does the limit go to 0? Is the limit as n goes to infinity equal to of 1 over the square root of 1 over the square root of n plus 1? Does that equal 0? Yes. So by the alternating series test, this thing converges. So let x equals 1. Okay. By alternating series test, it converges. Okay, that thing converges. Okay. So we know that 1/3 works. What about the other one here? What about the summation? Okay, let x equal -1/3. Summation of n equals 0 to infinity of -3 to the nth times -1/3 to the nth all over the square root of n plus 1. What happens to this thing? Okay, well, this thing is equal to the summation of 1 to the nth over the square root of n plus 1, n equals 0 to infinity, which is the same thing as 1 over the square root of n plus 1, n equals 0 to infinity. Okay, which this I can compare to a p-series, or can I? What can I do here? Can I compare it to a p-series? Okay, because I know that 1 over the square root of n is 1 over n to the 1/2, and I know that that guy diverges, right? Diverges. Okay, so 1 over n to the 1. So what I'm going to do is I'm going to do limit comparison test on this thing. Okay, I'm not going to do comparison test because I think it's going to go the wrong direction. Where'd my thing go? Oh, got slid over. Hello? Slide it back over, please. Okay, and slide it up. There we go. Okay. Okay, there we go. Nice, nicely done. Pull it over. And up. Bring it around town. Okay. So this thing I know diverges. So it's really small now. Okay. This is n to the 1/2. That diverges, okay? So if I try a basic comparison test, 1 over n plus 1 to the 1/2 is less than or equal to 1 over n to the 1/2. The only problem is it's going the wrong direction. Okay, this thing diverges. I want something that's bigger than a diverging, right? If it diverges, it goes like that. I want something bigger than a divergent, not smaller. Okay, so this would be like 1 over n to the 1/2. This would be 1 over, no, this would, the top would be 1 over 1 over n to the 1/2. The bottom one, slightly smaller, would be 1 over n plus 1 to the 1/2. Okay. Okay, and it goes the wrong direction. However, I can do the limit comparison test. Okay, even though it goes the wrong direction. Okay, so let's go the limit comparison test. Limit as n goes to infinity of, okay, of a sub n over b sub n. Okay, so the limit as n goes to infinity of 1 over n plus 1 to the 1/2. Okay, let me think about this for a second. Okay, that really doesn't matter. Okay, all over 1 over n to the 1/2. Okay, so, and it's not absolute value. I don't think it's absolute value. I think it's just a sub n over b sub n. A sub n over b sub n. Okay, the limit of this thing. Okay, what is that going to be equal to? Well, this is going to be equal to the limit as n goes to infinity of n to the 1/2 over n plus 1 to the 1/2. Okay, so then this becomes, I'm just going to start using square roots here. Limit as n goes to infinity of the square root of n over n plus 1. And what does this thing go to? Well, this thing goes to 1, right? So I'm just going to say that thing goes to 1. Okay, you can prove that to yourself if you really want to. But that thing is going to go to 1, which means what? Which means that it has a limit. This thing has a limit, which means what? Which means that these either both converge or diverge. So that tells me that they both are divergent because I knew the other one is divergent. So what does it tell me? It tells me that when x is equal to negative 1/3, this thing diverges. Okay, so negative 1/3 does not work, but positive 1/3 does work. Oh, okay. So there's my interval of convergence. Okay. Okay. So I'm going to go and back to the homework now. Sorry, I didn't mean to cut you off if you weren't finished copying down. Okay, so there was a homework problem. Victor, you still want to go over that homework problem? Okay, so we got 3 sections left, which is good. Okay, so 9, 10, and 11 to finish up tomorrow and Thursday. Oh, right on track. So I'm going to stop my recording again. I'm going to stop my sharing. I'm going to stop my recording. It was 11 on 11.5. Okay, so 11 on 11.5. Sounds good. So